Hadoop as an ELT, an exercise with Hive. A large retail firm was using MicroStrategy for generating everyday reports. The bottlenecks in MicroStrategy were: time taken to generate report was going up with an increase in number of metrics. Developer time to write KPI logic is more. Scalability was a major issue. Number of columns that can be generated in MicroStrategy is limited. The current architecture in production is as follows. Transaction data is stored in Teradata. MicroStrategy pulls the data from Teradata and computes the metrics in cubes. The report thus generated is stored in MongoDB. The reports were finally pulled up from MongoDB into a web app. We had to stick with the input source as Teradata and output as MongoDB. We proposed Hadoop along with other components of the Hadoop stack. We included Hive and Scoop for the current architecture. We opted to use Hive, as the data from the retail store was in structured form. Hive is a SQL-like tool on top of Hadoop for processing data in structured form. Scoop is used as a data loading tool. The transaction data is primarily stored in Teradata, and Scoop is used to load data from Teradata into Hive. We process the data in Hive and generate reports. We have written custom mapper function to output the report generated by Hive into MongoDB. Here we are using MySQL as an RDBMS instead of Teradata. MySQL is being used as an input source for data. Selecting the schema and describing the table. A small subset of the data from Table 1. We see the metadata of the table and first few samples data from the table. Now exit the MySQL shell. Next we open Hive shell. Command Show Databases is used to view the available databases. Select the database work.db. We now create a table to store the data being imported from MySQL. We name the table POC Demo. The table contains the columns same as the ones described in MySQL. Hive shows OK to tell the command is executed successfully and the time taken. Use command describe formatted POC Demo to view the metadata of the table POC Demo. Next we will import the data into Hive from MySQL using Scoop tool. This is the Scoop command to import the data from MySQL into Hive. We specify hostname of the MySQL server, username and password to login, table to import from MySQL and table to store data in Hive. Scoop launches map tasks to copy the data from MySQL into HDFS first and then from HDFS to Hive. The HDFS is a temporary location to hold the data while importing. We see job information and the time taken to complete the import job. We now launch a custom mapper Hadoop job to transfer data from Hive to MongoDB. MongoDB is our target location. The reports will be fetched from MongoDB. The Hadoop job is launched and we can see the job information. After the job is completed we can see the time taken and other related information. Now we launch the Mongo shell to check if data transfer is successful. Show DBS will display the databases. Select the database test. We have used the demo table to store the data. Type command dbdemo find pretty to view the data in formatted output. Hive strengths for this architecture. Scalability is no more a bottleneck. Faster processing compared to MicroStrategy. Hive runs on a distributed mode against the single machine mode for MicroStrategy. Column limitation for report was overcome. Seamless integration between Teradata, Hive, Hadoop and MongoDB. Any number of metrics can be calculated with a large amount of data. Developer time was very less compared to MicroStrategy. Insurance against data loss, as Hadoop stores each file at least 3 times.